Isosceles triangle. Isosceles triangle. This is something that all of you guys have worked with. This is something that each and every single one of you knows what it looks like. When you have an isosceles triangle, what makes it isosceles? Do you remember? What's that? No, that's scalene. Scalene is what. Very good. So an isosceles triangle is a triangle that has exactly two sides the same. Isosceles triangle has two sides the same. Two congruent sides. Now, when we define isosceles triangles, the angle that is between the two congruent sides is called the vertex angle. The vertex angle is always the second letter when you name an isosceles triangle. So if I call this triangle A, B, C. Excuse me. If I say we have isosceles triangle ABC, if you see, anytime you say, or they say that you have an isosceles triangle ABC, XYZ, RST, whatever, that middle letter, come up. Oh, I see, none of that. Excuse me. I don't. That middle letter is always the vertex angle. That means that's always going to be the point that the other two sides connect to that are congruent. So that's always the vertex letter. It's always the vertex. And that means that AB is congruent to BC. That's how the lettering works with that. Okay? That's how the lettering will always work with isosceles triangles. Middle letter is the vertex. It's the repeated part that shows the two congruent sides of the triangle. Does that make sense? I don't know if you guys heard those terms before. It's a little bit different than just having the two sides being the same. The other part of an isosceles triangle is that these congruent legs or congruent sides, they look at congruent angles. So an isosceles triangle has two congruent sides and two congruent angles. Yep. The two angles are always opposite the congruent sides. The two angles are always opposite the two sides. And that kind of leads us into like an if-then statement, if you will. And this if-then statement isn't a bad idea to have on your progression sheet. If not for just helping remember some of the algebra that we'll come across. Isosceles triangle. If then If you've got the two sides congruent, then you have the base angles. That's what that means. And it goes the exact opposite as well. If you have the base angles congruent, then you have sides congruent. The sides are always opposite the angles. The angles are always opposite the sides. And that pattern will always hold. That pattern will always hold. Very simple if then statement. Which means when we start talking about this stuff in terms of like algebra and whatnot, is that if you happen to have, I don't want to get too far ahead here. You guys all good on that one? So if you wind up with information like, let's say you have this isosceles triangle XYZ with angle C equal to 43 degrees. So if I say we have an isosceles triangle, the isosceles triangle is XYZ, and I have angle Z equal to 43, you should be able to tell me the other two angles. All right? So what should you do first? Which one's the vertex? Good. So we draw it. We know that Y is that vertex angle. If Y is the vertex angle, what are the two sides that have to be congruent? Good. Those are the two sides. You were getting ahead of us with the angles. What are the two angles that have to be the same? Z and X. Good, good, good. See where I'm going with? They look at each other. And if I know that Z is 43, what's X? 43. What do you do to figure out Y? Subtract from what? 180. That's all right. That's all right. Because there's how many total degrees in a triangle? 180. If you have 86 degrees there, how much is left? Go. Yes, ma'am. That's what you'll be able to do. Okay. The sum of the angles inside of a triangle is always, always, always going to be 180 degrees. That doesn't change. Very good. That's how the triangle will always be 360. Very good. Okay. We'll get more into that stuff. No. Actually, we do that right before class. Some exterior, some angle stuff like that with that before. Go right before break. Pretty fast. All right. All right. All right. What about equilateral triangle? All sides. Good. So equilateral triangle. Equilateral triangle. Again, you guys know this. It means all sides are congruent, and it also means that all angles are congruent. If you have three angles in a triangle, and all three of them have to be the same value, that means all three of them will add up to equal, or excuse me, all three of them will have to equal 60 degrees. Work with equilateral, when you label the equilateral triangle, it does not matter. It just equilateral, you have an equilateral triangle, ABC. Just means that all sides are the same, all the angles are the same. It does not have a vertex angle to worry about. It's just equilateral. Right? There is nothing to worry about with that. Again, something very simple that I like to put on our progression sheet. You can probably fit it on the same square with the isosceles one if you've got a little bit of room on there. is that you could also do this, just so you have it, that you know that equilateral. What's that? There should be some more towards the front. So if you've got all three sides, then you've got all three angles. And again, if you have all three angles, then you have all three sides. And this little note, angles always equal 60. Never changes. Never changes. Super simple, straightforward stuff. Kind of nice when it's not proof, isn't it? Yes. Like I said, we're coming to the end. We're coming to the close. We're getting it. So this is chapter 4. What do you mean? They still show up from time to time. Yeah, we actually, the equilateral triangle is one of the more important triangles that we work with as we get into trig with right triangle stuff, because there are specific things to this that is the entire basis of all trigonometry. Trig? It shouldn't be. Now, real quick, yes, ma'am. Some schools used to do that, whereas in Algebra 2, and then you do trig. But it started to become more of just a part of Algebra 2. The stuff we do in geometry with trigonometry is just some real basic introductory stuff as far as side lengths and angle stuff with sine, cosine, tangent, things like that. But one of the things that we will see a lot of is, if I call this an equilateral triangle, all those are the same, right? That means all of these angles are 60. Now, if I bisect this 60-degree angle, and that means that's 30. The other half is 30. So if I'm looking at just this triangle here now, what does this angle here have to be? Right angle, it's got to be 90. Very good. Oh, don't write this down. Don't write this down. Okay. Now, what if I say my side lengths are 4? You guys okay with that? These would have to be 2s, because when you are perpendicular in an equilateral triangle and you bisect this, you actually bisect that as well. Now, what theorem in math allows you to find the missing leg in a right triangle? No. A squared, B squared, C squared. Which of these values in this triangle is the hypotenuse? The side length, that's 4. So we would say something squared plus 2 squared is 4 squared. All right, what's 4 squared? What's 2 squared? So I get x squared plus 4 is 16, so x squared is 12. Press button in your calculator, you get x equals 2 root 3. Right. Now, if I change those values out to be 14, that would make this how much? 7. And then actually that would make this then 7 root 3. This square root 3 continuously shows up opposite the 60-degree angle. Yes, sir? The root 3, yeah, there's a pattern that occurs here. So what happens is, using this 30, 60, 90 triangle, sorry, it's really badly drawn. That's 30, 60, there's 90 degrees, 120, 150, 180, 210, 240, 270, 300, 330, 360, very good. So what happens here is that for each of those values that goes around, this number here, when you're opposite your 30, that makes a 90-degree angle there. So then you're looking at sine of 30 is what? That's 1/2. So, and this is root 3. So this value here in an ordered pair, is that 1/2 an x coordinate or a y coordinate? Think of ordered pairs. Is it the x or the y? The y value. Y values go horizontal. Okay. So if I move that to here, my y value stayed the same, didn't it? So it's still something 1/2. If I move that value to here, I reflect it, my y value is negative 1/2. I move it over here, it's still the same line, it's something negative 1/2. That simple triangle gives you what's called the unit circle. What's that? There was a triangle, but this triangle here, and then when we get to 45, 45, 90 isosceles triangle, those two triangles become the basis of all trigonometry in Algebra 2. So we spend a good chunk of time looking at how this stuff works, how you can do some simple values, simple calculations, second semester. But then next year, you get into a lot of this. This looks awful right now, but it's the same thing repeated over and over and over. Okay? But anyway, so we did this. Those guys did this, talked about that. All right. Is that an equilateral or an isosceles triangle? It's equilateral. If one side is 15, what are the other sides? 15. Are we mathing okay here? So far, okay. I'm trying not to make this too difficult. I mean, I can. Oops, wrong one. Pull that up. Which means we'll be able to take this one might take a minute. Okay. So I'm going to figure out what is x and what is y. Now, if you take a second to draw this one through, yeah, this is about as complex. This is about as complex as things get. I know it's not the easiest one to draw. I'm sorry about that. If I were going to draw this one, I would draw the bottom first. I would do my triangle like that. And then do this. All right, fancy pants. Yeah. Let's go. Well, so you can see it. Oh, come on. You can draw bigger than that. Why don't you put yours over here? There's plenty of space for you. You know. We'll see, you know.
Okay. Hold on.
I don't think we'll be able to see. I don't think we'll be able to see him draw it. So. I mean, you know, it's. Oh, I see what you're saying. I was saying that. It's all right. It's all right. Wow, trying to get the attitude of me there, huh? So anyway, a lot of times with these types of triangles, when you have big picture problems, your best bet is to try to figure out what's the easiest stuff to fill in. Perfect. Does everybody see that the triangle on the right, the VTU, that's an equilateral triangle? We know that it's equilateral. We know it's equilateral because all three of those angles are the same. So what I would do is I'd fill in the 12s. 12, 12, and SV is also 12. Okay. What about all three of those angles? How much are all three of those angles? All 60s. Good. So that's 60, 60, 60. Okay. What does this angle measure? 90. Good. So there's 90, which means what's that little wedge there? 30. Very good. This vertex angle, and why is this a vertex angle? Well, no, why is that a vertex angle? Because it's isosceles, very good. Because you've got an isosceles triangle here at SVT, so that's 30, which makes your base angles how much? No. If the base angles, remember it's isosceles, if that means these two angles have to be the same, because these guys are the same. How many degrees are in a triangle? 180. So you take your 180, back out the 30 for the vertex. What's half of 150? Okay. Bless you. Now, all that's left now is figuring out what this is. And again, isn't that the side length? Isn't that one of the side lengths of 3 in a right triangle? So what theorem do you use to find a missing side length in a right triangle? Pythagorean theorem. Which of those 3 side lengths is the hypotenuse, the C value? The 15. Good. So it's something squared plus 12 squared is 15 squared. So press some buttons on the calculator, you're going to get 15 squared, subtract the 12 squared, And I believe you should get a squared then is equal to 81, which means that value is how much? What's 9 plus 12? There you go. So you will have to work your way through a problem, but mathematically it's super simple. It's very straightforward. It's a matter of remembering how many degrees are in a triangle, remembering that if you have a vertex angle, subtract it from 180 to get the two base angles and so on. Yeah. Okay, let's try another one. Okay, I only got a couple more. Make sure I show you guys a little bit more of the algebra. Hold on. Whoa. Hold on. So, when you're looking at one like this, the first thing you have to identify, is it equilateral or is it isosceles?
Well, it could be isosceles.
Well, which is it? Correct. This one has to be isosceles, okay? Because the third side, like you guys are saying, isn't labeled. Nor is it equilateral because it doesn't show tick marks for all three of the angles. So this one is going to be isosceles with sides of 13. So those 13s look at the angles that are congruent. That means these two are the base angles. Base angles are just the ones that the sides look at. The base angles are congruent in isosceles. They don't have to be on the bottom, they can be on the sides, they can be anywhere. It's just the two sides that point at the angle, the sides that point at the angles, those angles are the base angles. So if those two are the same, you set them equal to each other. Okay. So you got variables on both sides of the equation, what do? Subtract, good. Subtract, good, you're gonna get 6x. Now, what would you do with that value of 7 to make sure you didn't ungoof? Substitute back in. 7 times 7 is 49, and 5 is 54. What's 7 plus 49? Hey, those two numbers the same. X was 7. 54.